the AI-900 Azure AI Fundamentals Crash Course. And today, essentially, for the next roughly 2 hours, we will be going from start to finish, a quick guide on how to ace your test. We're going to be going through all the content, and we're going to be giving you a few hints, and we're going to go through a few questions. And so by the end of the 2 hours, and after you go through all the documentation, you should be ready to ace that exam. So who am I? So my name is Cailin Feldman. I'm currently a technical specialist intern at Microsoft, and my mate here is PK, and he is a student, and he's honestly a kick-ass Microsoft student ambassador, and he's currently at the beta level. So right now, our process, what we're going to do, the AI exam, we're going to go through the AI workloads, we're going to go through computer vision, natural language processing, machine learning, all of that to get ready for the exam. So some really crucial links for this course. One is going through the Microsoft documentation. This is a free learning guide. It covers every single documentation you need to read before you take your exam. So 100% go through that. The next is a video recap. So the current link is Michelle Stanford's one, which is an iconic course. And then if you have any voucher requests, please message Michelle Stanford on LinkedIn. As well as here's the link when you have that book exam, once you do our course, once you read that documentation and you're ready to ace AI-900 to put on your LinkedIn, you go on that course right there, that link right there. And also, we don't have any study notes provided, but if you want some, again, kick-ass, that is the word for the day, kick-ass study notes, go on to Michelle's GitHub. Okay, so the agenda for today. So first, I'm going to take you through an intro to AI, and I'm going to take you a bit about machine learning, and then PK is going to take over and do computer vision, NLP, and conversational AI. And a quick thing, if you guys haven't done a Microsoft exam before, they're chill. Don't stress. Essentially, it's about roughly 1 hour, and you'll need about a score of 700 out of 1,000. And please, my advice to you is answer every question. This isn't one of those nasty exams where you would be penalized if you get a mark wrong. It's not that the case at all. And also there is that little place where you can review later, comment later. Please check out keywords and make no assumptions. But you guys, if you watch our course, read the notes, do the documentation, you'll do well, so you won't need to stress. All right, let's get started. So here's a nice little summary of AI, but it's going to be quite daunting. So I'm going to go through it. Don't stress. But essentially, this is a nice little screen capture of what AI workloads is. So feel free to stop the video, take a screenshot for your study notes. So AI workloads, and this is kind of the way that the Microsoft exam study guide is done. So first, I'm going to cover what is AI, some common AI workloads, some AI in Microsoft Azure, and then we're going to go through responsible AI. So the challenges and risk with AI and principles for responsible AI. All right, let's actually get started, team. So what is AI? Essentially, in a really nice sentence, it is software that imitates human capabilities. Sounds really cool and really exotic, but essentially what that means is that we're replicating our brains onto a computer, teaching it how to think, how to learn, how to identify. That's what AI is. So it's systems or machines that mimic human intelligence to perform tasks and iteratively improve themselves based on information they collect. So some examples could be chatbots that use AI to understand customer problems faster and provide efficient intelligence, and also intelligent assistants that use AI. Think about Siri or Alexa. Also Netflix, recommendation engines that can provide automated recommendations for TV shows based on user habits. So AI is much more about the process and the capability for superpowered thinking and data analysis that any can be. So now you know what AI is. So what are some common workloads? So we're going to be going through a lot of these more in depth, but I'm going to quickly go over them all. So first, we have machine learning. So that's identifying prediction forecasting workloads. Then you have anomaly detection. So that's the process of ML using to find unexpected values or events, enabling preemptive action. Then we have computer vision. So that's applications that interpret visual input from cameras, images, or videos. Then with NLP, so that's applications that can interpret written or spoken language. And then we have conversational AI. So that's agents that can engage with dialogues with human users. So machine learning, how does it work? So as I briefly said, machine learning is identifying prediction and forecasting workloads. So it's using historical data to predict an outcome based on the data input into the model. So machine learning, essentially here's kind of a little fun GIF to show how machine learning works. So one, we have a team of botanists and scientists to collect data on wildflower samples. So I love flowers. And then next is that the team labels the samples with the correct species. The labeled data is then processed using an algorithm that finds relationships between the features of the samples and the labeled species. Then the results of the algorithm are encapsulated into a model. So then when someone else finds some fun little wildflowers, so some volunteers find some new samples, the model then can correctly identify the species label. So it can pick up a flower from somewhere from their garden and then put it into the model, and that model will be able to tell you what exact kind of flower that is. So that's what machine learning is. And then we have anomaly detection. So anomaly detection is the process of using machine learning to find unexpected values or events, enabling preemptive action. And so anomaly detection. So it's the capability to automatically detect errors or unusual activity. So essentially what it is that it's constantly monitoring something. So here, number one, so the sensors in the car collect telemetry such as engine revolution, brake temperature, and so on. And then number two, the anomaly detection model is trained to understand expected fluctuations in the telemetry measured over time. So in number three, as you can see here, if the measurement occurs outside the normal range, the model reports an anomaly that can be used to alert the race engineer, to call the driver in for a pit stop, to fix the issue before it forces retirement from the race. So this is really awesome. So essentially what anomaly detection is that it's just a model and it's constantly just monitoring something. So here it's just constantly monitoring the car, just making sure all is good. And as soon as there's a metric that's a bit outside the range, completely like, up way out of scale, then the AI is going to alert the engineers going, no, this is not right. This model here, like this number is wrong. Fix it. It's going to ruin something or it's going to have terrible consequences. So then the AI then alerts engineers, and then the engineers will then come and fix a car, and then all is good, and it will save massive disasters. So that's what anomaly detection is. Essentially, in a summary, just making sure everything's normal, and if it's not, it will freak out, alert you, and then it will then kind of do its thing. So it kind of just sends alerts, and then you, as a person, will need to fix whatever is done. Then we have computer vision. So there's quite a variety of things with that, but essentially what it is applications that interpret visual inputs from cameras, images, or visions. So it's that capability of software to interpret the world visually through cameras, videos, and images. So there's quite a few examples and quite a few things that computer vision goes into, but I'll quickly just run over it, but later in the session, PK will speak more about them. But essentially, you have things from image classification to object detection to semantic segmentation and just a bunch of other things, creating tags, face detections, optical character recognition, all these really cool things you can do with AI. That's what computer vision is, but we'll expand on that more later in the session. And then we have NLP. So this is the applications that interpret written or spoken language. So think of computer vision as the images and NLP is more of the written text. So it's the capability for a computer to interpret written or spoken language. So example here, you can see here you have smiling, you have this sentiment analysis when it's a text going, I'm great. Sentiment analysis will go, yep, that obviously is a good thing. Then you have something a bit more basic like, it's okay, or where are you? Just a kind of plain neutral answer. That would be obviously a neutral sentiment. But then you have something like, this is awful and overrated. Then you would have that obviously would be a very negative sentiment analysis. So then also lastly, you have conversational AI. So these are AI agents or bots So think of it from every time you go, I don't know about you, but I love like my good online shopping. And so you'll go into an online shop and then you have a little chatbot IM that comes up going, hi, how can I help you today? And if you have any concerns, everything like that. And it's getting really good nowadays. It's honestly becoming very, might be passing the Turing test sometime soon. But anyways, essentially that's what chatbot is that little FAQ chatbot. That's what they are. That's conversational AI. Cool. So we've learned what AI is. We've learned some cool workloads with AI. Where can we use this? I want to, it makes you, I don't know about you, but if I was you, I would just want to get started ASAP. And I mean, I still always do. Well, using the Microsoft Azure platform, we have Azure Machine Learning. So that's a platform for training, deploying, and managing machine learning models. Then we have Azure Cognitive Suites. And that is a suite of cognitive services developers can use to build solutions. And then we have the actual bot services. So that's a cloud-based platform for developing and managing bots. And there's a few other services that I will go through, such as automated machine learning and things like that, but I will expand later. Okay, so a little break, a little pop quiz for you. Just to kind of break it up, I'm going to ask you a question and we're going to go through multiple choices. This is a very good example of what the exam like. But this is kind of good AI workloads. Would it be A, detecting language and then provide a text document, B, providing pedestrians in a real-time video of an autonomous vehicle, I can't speak, C, predicting whether a plane will arrive early, on time, or late, or D, providing answers to customer chatbot. So, drumroll, the answer is C, because A is language detection, B is vision workload, and D is going to be bot related. If there's chatbot, you know it's going to be conversational AI. So it has to be C. I will do one more. So is the process of using machine learning to monitor and detect unexpected items or events in time series data that differ from the norm. This is going to be A, anomaly detection, B, prediction, or C, knowledge mining. We know it's going to be A. We spend a bit of time on that, how that's machine learning. It's going to constantly monitoring, checking values, making sure it's all in the range, the expected range. If it's not, then it's going to freak out. So that's what anomaly detection is. So now on our second lesson, responsible AI. So all of us are, AI engineers. We are. I've allocated you. I've told you we're all AI engineers. And now we've got, but with this title comes a lot of responsibility because, and I know that sounds dramatic, but it's truthful. There is so much we can do with AI, which is incredible. It's one of the things that I adore about AI. But again, for that power comes a bit of responsibility. So, and there's a bit of challenges and risk, and that's what I'm going to go through this session. So first of all, we have some challenges. So one could be a bias can affect results. So think about how a loan approval model can discriminate against gender due to bias in the data, which was trained. Or then we also have errors that can harm. So like I was saying, a lot of cars, that example with anomaly detection, how an F1 driver, they want to make sure that the metrics is all good. And if it's not, then the anomaly detection will pick that up. But what if it didn't pick it up? What if the F1 guy kept going and then something disastrous happened? So there can be absolute harm with this. The next one can be data could be exposed. Obviously, to make AI, you need data. You need so much data, and some of that could be private, some of that could be, and if there was a data breach, that's something that you need to be prepared for. You need to not be prepared for, you want to prevent. So that's something you need to take into account. Another thing that you've got to also, another challenge and a risk that comes with AI is that solutions may not really work for everyone. We need to be inclusive. And so that's what I'll expand on in the next few slides ahead. And the last one is that we need to figure out who is liable for an AI-driven decision. So here we've got the example of an innocent person is convicted of a crime based on evidence from facial recognition, but it could be false. It could be incorrectly identify this person. So if they send this person to jail and then time comes out that it was an incorrect assumption, it was incorrect it was incorrect prosecution, who's going to be at blame? Are they just going to blame AI? But would you blame the person that made AI? That's something that needs to be in consideration. So you've gone through some challenges and some risks. Now, to almost avoid or to take all those things into consideration, we have these principles of AI. So we have fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. And before I go through every single one, here's a nice little screen capture of them all. So again, if you want, you can take a little screenshot of this for your study notes. So one, we have fairness, right? So the idea is that every system should treat people fairly. And as I was saying before, you could create a machine learning model to support a loan approval, and this model should make a prediction whether the loan approval should be approved or not without any bias on gender, ethnicity. So that sense of, but what's really awesome is that Azure ML actually includes the capacity to interpret models and quantify the extent to which each feature influences the model's prediction. So, for example, their skin tone or where they're from, their tax bracket, you can see how much it really heavily impacts. And then from there, you can obviously alter and, maybe potentially take out features. That's what we could do in the ML, which is really impressive. So that can be a way of making sure that it's fair, following that principal guideline. Secondly, we have reliability and safety. And I've explained that before with that kind of vehicle, right? How it needs to make sure that AI systems are tested again and again. So, it's reliable and safe. Again, because there can be a lot riding on these AI models. Exactly. There can be a lot riding on this anomaly detection, making sure that it's always working, it's never going to stop, or if the internet's going to be right, you need to make sure that everything's fine. So that's where reliability is. So then, it's good. So AI, exactly right here though, what's a good summary point is that AI software development must be subjected to rigorous testing and deployment management processes to ensure they work as expected before release. And, you're going to have a consistent outcome. You're not going to have one going, oh, maybe this round we're going to get this value, and that round you're going to get different values every time. That's not what we want at all in a AI model. You want consistency every single time, and that's done, and that's proven through rigorous testing. Then we have privacy and security. So we want to make sure that AI systems are secure and, again, respect privacy. So we have the machine learning models on AI systems which are based, and rely on large volumes of data, which again has personal data that needs to be kept private. So even after models are trained in systems, so this could be a matter of how you need to encrypt your data at rest, or things like that, or a matter of getting consent with your users and your data. So that all needs to be done when you're creating these AI models. And the next step would be inclusiveness. So AI, you want to empower people because, like I said, we have so much responsibility as AI engineers, and there's so much we can do with it. We want to make sure that our almost superpower is going to help people. We want to make sure that everyone from all different genders, race, all that is going to be empowered. So that's going to be something you always want to keep in the back of your mind when you're making these AI models. And then we have accountability. So that's what I was explaining before. We'd have, if it comes to prosecution, to I would say maybe even medical, what's it called? Medical identification, classification, figuring out if person diseases, diagnosing, that's right, medical diagnosis. So obviously there's going to be a lot that can be done. And so you would want to make sure that if this AI does an incorrect diagnosis or an incorrect assumption that leads to someone getting, incarcerated, you want to figure out who would actually be accountable. So that's something, again, when you make these AIs, these brilliant AIs, the fact that these AIs can use, countless data to make these end results, you want to still make sure that someone is just accountable. You don't want to just blame an AI on this. And then we'll have transparency. Because right now, I think besides obviously us engineers who are building the program, but it can still be almost a bit of a black box when it comes to machine learning and AI. So we want to make sure that the AI systems are understandable and users are made fully aware of the purpose of the system and how it works, what it works, the limitations, the process of how it was made, where the data was extracted, everything like that. You want to make sure that's all clear. We don't want to go like, oh, I've made a model, just accept it, just use it. No, that's not the case at all. You want to explain, you want to share your knowledge. You want to make sure that it's just a clear box, not a black box. We want a clear box. Cool. So my question is, company gives clear explanations of how banking AI system works, what factors it considers on improving mortgage applications. Which responsible AI principle is this an example of? So we're going to go from the bottom up this time. Is it going to be reliability and safety? Maybe. Fairness? Yeah. Accountability? Maybe. Inclusiveness? True. But I'm going to be A team. It's going to be transparency, because you explain clear explanations of how it works, what factors are being proven. These are all key words when it comes to transparency. One more question. So, company carries out rigorous testing and deployment management of an AI system that powers a driverless taxi solution. Which principal AI is this an example of? Transparency, inclusiveness, accountability, fairness, or reliability and safety? It's going to be E, because it's rigorous testing and deployment. And that's for that reliability thing and making sure that it's safe, making sure that you're going to get consistent results every single time. That's what reliability is. And safety, obviously, if you're getting consistent results. Cool. So that's our module 1 done. Well done for making it this far. And now we've got module 2, which is machine learning. So again, here's a lovely, beautiful kind of summary of machine learning Azure. I will let you take a screenshot in a minute, and then let's get started. So the learning objectives for this module, you're going to learn what machine learning is, what regression, classification, and clustering is, and we're going to learn a bit more about Azure machine learning. So what is Azure machine learning? We're going to learn about automated machine learning and Azure machine learning designer. It's really cool. Heads up. So what is machine learning? In a really beautiful line, it is creating predictive models by finding relationships in data, which that's pretty lovely. So you can think of machine learning as, process of these 4 steps. 1, we're going to prepare the data. So we're going to identify the features and the labels in the data set, pre-process it, clean it, and transform the data as needed. So 1, prepare the data. 2, we're going to train the model. So we can split the data into 2 groups, training and validation. So we're going to train the machine learning model using a set of trained data, and then we're going to test that machine learning model for performance using the validation data set. And then our 3rd step, that's evaluating the performance. So we're going to compare how close the model's predictions are to the known labels. And then lastly, 4, we're going to deploy our predictive service. So after you train your machine learning model, you can deploy your model as an application on a server or device so that others can use it, which is pretty cool. So now we know what machine learning is. So let's go through a type of machine learning. This is regression. So regression is a form of machine learning that is used to predict a digital label based on the functionality of an item. So for example here, suppose we had VentureWorks, right? So this is a company that could use historical data for a model that predicts daily demand to make sure there's enough bikes available. So as you can see here, I'll explain it a bit more. So essentially, obviously, most data sets, most machine learning models are multivariable. They don't have just an X and Y. However, in this example, for explaining purposes, teaching purposes, we can use X and Y, as it's very nice to visually show. So here we have some historical data. So we have a bunch of temperatures, and we have the amount of and how many bikes were rented that day. So what we do is we plot every single point. So on the X and Y, so on temperature where it was 56, we had 115 people rent that bike. So you would plot all those lines, plot all the points on that graph. And then what you're going to do is you're going to make that line of best fit. So you're going to try capture as many points on that line as possible. And so then from there, we create a beautiful linear line. And, going back to your primary school days, y equals, it wasn't primary school, maybe early high school, but y equals mx plus c, we're going to create that equation. And then from there, we can plop in new values and get out suggested values. So we can put in, we can say, oh, I'm curious about what the temperature is going to, not temperature, how many people are going to hire a bike at 60 degrees. So what we'll do here in this case, because we've worked out the grading, we've worked out the y-intercept, so we're going to plop in 40 degrees into that equation, and it's going to come out with an x value or a y value, and so that'll be your number. So so it's got a bit of a kind of a guide and a bit of an estimate on how many people would have rent that bike for that temperature. We've gone through regression, so that's all numbers. And then we have classification. So this is another form of machine learning used to predict what category or class an item belongs to. So for example, a clinic can use a patient's characteristics, such as age, weight, blood pressure, etc., to predict whether the patient is at risk for diabetes. In this case, the patient's characteristics are traits, and the label is a classification of 0 or 1, representing non-diabetic or diabetic. So there's a few examples of classification. You've got Cailin and random forest, supported vector machine. So there's a fair few examples. So you can, it's checking whether and one that's quite relevant to a lot of us is checking whether our emails are spam or not. So sometimes every so often when I'm bored, I will go through my spam email, and it's quite cool how my Outlook can kind of figure out for me what is spam and what's not. And that's just through machine learning. That's through classification. And then lastly, we have clustering. Clustering is a form of non-supervised learning, but I just realized I didn't explain to you the difference. So supervised learning is using past data to create machine learning models, and non-supervised though, there's no label data. It is them figuring out for its own. So essentially here, so for clustering, it's a form of non-supervised of machine learning used to group items into clusters or clusters based on similarities in their functionality. So for example here, what we would do is we have all our data sets. So we have the width and the height or length, number of petals for each flower, and we're gonna plot all those on there. And essentially what happens is the data then gets grouped into little similar characteristics, going, oh, we have the same number of petals or similar number of petals, similar number of height and width. Let's be a group. So they group themselves. There's no which is a pretty awesome thing. So there's two types of clustering. So you have hard clustering. On hard clustering, the data point is assigned to one cluster only, or then you have soft clustering. So it provides the probability or likelihood of a data point to be in each of the clusters. So some examples of clustering could be to learn about purchasing habits of e-commerce clients, or grouping together online shoppers with similar traits for targeted marketing, and figuring out what people tend to buy together. Do they normally buy nappies? If they're buying nappies, do they buy a certain baby food? So it's kind of that data that's clustering. So it's figuring out what groups together and then how you can use that. So for example, it could be that the Coles or Woolworths would identify through that clustering machine learning algorithm, figuring out, oh, okay, well, nappies and this certain baby food is always purchased together, maybe to get more sales. We can place those two together when it comes to placing products. So now we've gone through what machine learning is. I'm going to explain to you how we can actually use the platform, Azure Machine Learning, and how we can actually use this platform to do some really awesome ML. So what is Azure Machine Learning? It's a cloud-based service that helps simplify some of the tasks it takes to prepare data, train a model, and deploy predictive services. So regression models can be built using Azure Machine Learning models, which is really awesome. So it saves a lot of time. So to use Azure Machine Learning, you're going to create a workspace resource, and then you can use this workspace to manage data, compute resources, code, models, and other artifacts related to your machine learning workloads. So after you've created your Azure Machine Learning workspace, you can develop solutions with the Azure Machine Learning servers, either with the developer tools or the Azure Machine Learning Studio portal. So what does the Azure Machine Learning Studio actually look like? So this is a very nice little example of what it kind of looks like, but I'll quickly do a little screenshot. So you have these areas. So you have the authoring. So these are the ones where you can actually build and train your models. Then you have assets. This is all about managing your data, monitoring your jobs for your deployments. And then you have management as well, just making sure seeing how much space is actually being used. So we have Azure automated machine learning. This is insane. Honestly, it takes so much of the bludge work out of it. So automated machine learning is a process in which the best machine learning algorithm to use for your specific data selected for you. So in order to ensure automated ML, following the transparency principle of responsible AI, you should be able to enable explain best model option. So this explanation allows you to understand why that model was selected and how that model works, and enables you to meet regulatory requirements and provides transparency to users. So essentially how it would work is that you would, it's as simple as, we'll do a demonstration in a different video, but essentially how it works is that you would pick the data set that you would want, you would pick your targeted variable, your outcome, you would place it in, and then the automated machine learning will figure out, maybe SVN or Cailin or something like that. One of those models is the best one for you, and then explain why. So it saves so much time when you coding through your program and changing the libraries every single time, changing models every single time, and having to do the accuracy yourself. It's all done for you. And all you need to do is just literally select, literally put in the data set that you want to create a model with and saying what your target variable is. Literally easy as that. Then for my visual learners out there, I don't know about you, but I have a billion thoughts going in my head 24/7. And so but also a way to learn, a way that I can put all my ideas into a paper, if I can do that through a drawing, insanity. So that's what honestly Azure Machine Learning Designer is. So it's to use visual interface called Designer that can help you use to train, test, and deploy machine learning models. So it's a drag and drop interface that makes use of clearly defined inputs and outputs that can be shared, reused, and version controlled. So each designer project, known as a pipeline, has a left panel for navigation and a canvas on the right-hand side. To use Designer, identify the building blocks or components needed for your models, place and connect them on your canvas, and then you can run a machine learning job. And that's all just through drag and drop and placing in. It's so cool. And then we also have a few examples of just some common features of model training and evaluation. I briefly mentioned it before, but it is good for learning just a bit of that reiteration. So essentially some steps for machine learning process. One, we're going to prepare that data, and then essentially here, right? So you have the AI-900 results. And then we're going to identify the features and labels in that data set, pre-process, clean, transform the data as needed, right? And then two, so that's also, see, that normalized data, that's part of that cleaning process. And then number two, train the model. So we're going to split the data into two groups, training and a validation set. So we're going to train a machine learning model using the training data set, and we're going to test the machine learning model using performance, using the validation data set. And then third, we're going to evaluate the performance. So we've split our data into that training and validation test. So as you can see here, after that score model, so we're going to use that validation model to see how accurate the actual predictions are compared to the actual values and predicted. And then lastly, it's going to deploy a predictive service. So after you train your machine learning model, you can deploy a model as an application on a server or device so that others can use it. So to measure the accuracy of the predictions and assess model fit, you should evaluate the model. So once the model is trained and scored, you can evaluate the scores to measure the accuracy of train performance. So that's what you would do in that, obviously, that stage with valuation. So I've gone through machine learning, so let's do a few questions. So the question is, predicting the online sales volumes for the next financial quarter, what example of machine learning is this? Is it regression, classification, or clustering? We know it's regression because it's got to do with numbers, it's got to do with predictions, so you know that's regression. And then my next question is a machine learning method that predicts / determines the category, type, or class of the data item. So what would that be? So classification, clustering, or regression. So we know it's going to be A because it's a supervised learning method, and it's going to be predicting categories and data types. And we know that's what classification is. So thank you for listening for me, everyone. I'm now going to pass over to PK. And I'll stop sharing as well.
Thank you, Cailin. Hi, everyone. Let's jump right into Module 3, Computer Vision. So primarily, you'll be learning two concepts here. The first is computer vision concepts, and secondly, computer vision in Azure. This is a mind map of the topics we'll be covering under computer vision. So mainly we have image analysis, form recognizer, image classification, OCR, face detection, and object detection. So what is computer vision? Computers do not have eyes, but they can process images using cameras, videos, pictures to interpret the world. To an application, an image is just an array of pixel values. These values can be used as features to train ML models that Cailin discussed that can make predictions about the image and its contents. Most popular computer vision solutions are based on ML models that can be applied to visual input from cameras, videos, and images. There are common applications of computer vision. Image classification helps us to classify what is contained in an image. Object detection specifies the location of multiple objects in the image. And image segmentation will create a pixel-wise mask of each object in the images. So let's look at an example of image analysis with computer vision service. We have an image here on the right, and we can use the computer vision service to analyze this image. So you can see the service is able to identify a lot from this simple image, including captions, tags, and ratings. Now, this is an important concept for your AI-900 exam. The AI-900 documentation puts quite a lot of emphasis on understanding the different types of services of custom vision. On the left, we have image classification. On the right, we have object detection. In image classification, you see that the service returns just a tag describing the image. We saw this in a previous slide with the computer vision classified a taxi. And object detection works differently from image classification. As you can see, the computer vision service listed in the class of each object like orange, apple, along with the coordinates of the object, that's the colored boxes surrounding the objects with a confidence score. Face service allows users to use computer vision for facial recognition like similarity matching and identity verification. And it can also do some pretty cool things like picking up the age and emotions of the person detected. As you can see here, the face services manage to identify that the people in this image are happy along with the probability score. We can read text from images using computer vision service. This includes printed and handwritten text. And we can also analyze forms with form recognizer. Reading text and analyzing forms is something everyone is familiar with nowadays because you have used it at some point over the past few years on your mobile devices. So to overview what we just learned, we covered computer vision concepts. What is computer vision? Applications of computer vision in Azure, cognitive services, image analysis with the computer vision service, etc. So let's look at a question. Assessing damage to a car from a photograph is an example of what? So right off the bat, the answer is A, image classification. So as reviewed earlier, image classification is a machine learning model that predicts the category that the contents of an image belong to. How do we do this? A set of images is used to train the model. You train the model by uploading images of the vehicle with different levels of damage, and you can label them with the class labels that you want to identify. The model will then be able to place any new image in one of the categories. This can be utilized to even find the average cost of each level of damages. Let's look at the next question. So which of the following is a scenario where you would need to use an optical character recognition solution? Okay, so optical character recognition, OCR, extracts small amount of printed or handwritten text from an image. OCR can recognize individual shapes as letters, numerals, punctuations, and other elements of text. By using OCR, you can extract details from invoices that have been sent electronically or scanned from paper. These details can be validated against the expected details in your financial system. So we can say the answer is C. Now, this is an interesting question, and you do get quite a few of these in the AI-900 exam. You would realize that if you are creative enough, you could use OCR to find a workaround for all these solutions. So in such situations, you ask yourself if that service is the best use for the given scenario. Moving on, which two Azure Cognitive Services can be used to analyze faces within an image? So the answer to this should be A and B. Let me explain why. Azure Computer Vision and Azure Face Recognition Cognitive Services can be used to analyze faces within an image. Computer visions can detect human faces and predict their age and gender. You might be unfamiliar with option C, Personalizer, because it is not covered in the AI-900 content. But for some context, Personalizer is a cognitive service that can learn about user preferences from their corrective real-time behavior. Moving on, this is the final question for Module 3. That is the process of applying class or category labels to images according to their visual characteristics. This is image classification because that's literally the definition. It is the process of applying class or category labels to images according to their visual characteristics. You can use pre-trained image classification AI services or train your own image classifier with a custom set of images. Okay, moving on to Module 4, Natural Language Processing, or NLP for short. Once again, two primary concepts, introducing NLP and using NLP services on Azure. We have a great mind map showing you what we'll be covering in NLP. If you want, you can take a screenshot. Now, these are the components of NLP, and we have text analysis and entity recognition, sentiment analysis, speech recognition and synthesis, machine translation, semantic language modeling. You could build your own custom NLP models using machine learning or NLP toolkits for various programming language, particularly Python. Commonly used Python packages for NLP include NLTK, GenSim, and Spacey. But it's a complex area. Using off-the-shelf services can help you develop a solution more quickly and with less specialist expertise. We are going to explore all these services now. So this is how text analytics works. As you can see, we have a phrase, I had a wonderful vacation in France. The NLP text analytics service returns some great analysis from this sentence. We can see that the language is in English and the sentiment of the text is positive. Key phrase in the sentence is wonderful vacation and the entity is France. We use the language detection capabilities of the language service to identify the language in which text is written. You can submit multiple documents at a time for analysis. For each document submitted to it, the service will detect the language name, for example, English or Spanish, the ISO 6391 language code, for example, EN for English or RU for Russian, a score indicating a level of confidence in the language detection. Translation is pretty self-explanatory. We have translated text to speech, where we translate a text from one language to another. And we have speech service, where we translate a speech into text or speech into another language. The text analytics capabilities in the language service can evaluate text and written sentiment scores and labels for each scenario. This capability is useful for detecting positive and negative sentiments in social media, customer reviews, discussion forums, and more. Using the pre-built machine learning classification model, the service evaluates the text and returns the sentiment score in the range of 0 to 1, with values closer to 1 being positive sentiment scores, scores that are to the middle of the range, like 0.5, are considered neutral or indeterminate. A great example of this includes using sentiment analysis for the purpose of understanding public sentiment towards a political party during elections. Key phrase extraction is the concept of evaluating the text of a document or documents and then identifying the main talking points of the document. Consider the restaurant scenario discussed previously. Depending on the volume of surveys that you have collected, it can take a long time to read through the reviews. Instead, you can use the key phrase extraction capabilities of the language service to summarize the main points. Not only can you use sentiment analysis to determine that the review is positive, but you can also use the key phrases to identify important elements of the review. Let's look at speech recognition and synthesis. This is pretty basic, as we can use the speech to text capabilities of the speech service to transcribe audible speech to text, and the text to speech capabilities for speech service to generate audible speech from text. So let's look at an example and break it down. Suppose I say, switch the light on. The NLP detects light as the entity from the utterance and realizes that the intent would be to turn on the light bulb. Moving on to questions. Which two of these sources can you translate from one language into another? Each correct answer presents a complete solution. Choose the correct answers. So, text translation, translate the text documents from one language into another language. Speech translation, translate spoken audio from one language into another language. So we can say this is going to be text and speech. And just if you're confused about video, video can be analyzed and spoken, transcribed into text with media services. You can use text translation with the output from media services. The next question, AI solution identifies the main points in a set of blog posts which natural language processing workload is this an example of? Choose the correct answer. Well, AI solutions identifying the main points in a set of blog posts is an example of a key phrase extraction workload. So the answer is definitely C. It is an NLP process that automatically extracts key phrase to identify the main points in a collection of documents, such as a set of blog posts. So for a quick recap, we looked at these concepts for Module 4, Introduction to NLP. What is NLP? NLP in Azure using NLP services, text analytics, speech recognition and synthesis, translation, and language understanding. And finally, we have Module 5, that is Conversational AI. We'll be learning about conversational AI and conversational AI in Azure. Once again, we have a great mind map of the conversational AI, and we'll be covering the important ones for the AI-900 exam now. Do take a screenshot of it if you want. So this is what the bot framework looks like, but you don't have to go into details for the AI-900 exam, but it's quite interesting to learn more about it because it has some really intriguing content. If you do feel geeky and decide to explore Azure bot services, you can use this as a starting guide. Essentially, a conversational AI is a solution that enables a dialogue between an AI agent and a human. Generically, conversational AI agents are known as bots. Bots can engage over multiple channels like web chat, interfaces, email, social media platform, voice, etc. We have 9 responsible AI guidelines for bots. These are, number 1, be transparent about what the bot can and can do. Make it clear that the user is communicating with a bot. Enable the bot to seamlessly hand off to a human if necessary. Ensure the bot respects cultural norms. Ensure the bot is reliable. Respect user privacy. Handle data securely. Ensure the bot meets accessibility standards. Assume accountability for the bot section. You should know all of them by heart for your AI-900 exam. We also have Q&A Maker service, where we define a knowledge base of questions and answer pairs. by entering questions and answers from an existing FAQ document by using built-in chit chat. And finally, we have the Azure Bot Service, which is a cloud-based platform for developing and managing bots. It allows for integrations with Lewis, Q&A Maker, and others, and provides connectivity through multiple channels. Moving on to 2 questions from bot services. What is the most common use of a bot? Choose the correct answer. Well, interpreting an image uploaded by a customer, providing first-line automated customer service to customers across multiple channels, prioritizing customer emails by performing statistical analysis of the email's content, identifying the main points in a document uploaded by a customer. So I could say the answer is B. Bots can provide automated responses to customers. Bots can manage the conversation using a combination of natural language and predefined responses to guide the customer to a resolution. Bots can be deployed over many channels, including web chat, Facebook, Microsoft Teams. Providing an automated first-line response to customers over multiple channels is the most common experience users with the chatbots. Q&A Maker service. So which 2 Azure resources are created when a new Q&A Maker service is created? Each correct answer presents part of the solution. Choose correct answers. Okay, so Q&A Maker service requires an app service. The app service runs on the Q&A Maker queries. So D is correct. Q&A Maker service also requires Azure Cognitive Service. The search service indexes the knowledge base and performs intelligent services on the knowledge base. Therefore, the correct answer would be D and C. Well, I guess that's it. And so some helpful tips to remember before your exam. This is a fundamental exam. You are not required to have an in-depth knowledge of how Azure data services work. It's a simple exam format without any long-winded question, case studies, or complex scenarios. Stay calm, read the question, answer every question. Trust yourself and answer quickly, review later. Your best friend during the prep will be the AI-900 documentation, so do remember to go through the entire thing before you take your exam. Oh, well, finally, best of luck. With that, I would like to hand this back to Cailin and stop sharing.
Thank you guys for listening. PK did a perfect time wrapping up. Also, please get us on LinkedIn and let us know when you pass your exam, because yeah, we'll be really stoked, and I'm sure you guys are going to do absolutely so well. And for that, thank you and see you soon.